sets it wide.
We're wide.
Oh, we're live, are we? I see a red light.
We're live.
Are we live? We're live.
A 1, 2, a 1.
Welcome to Thinkative, the podcast for philosophers, seekers, and the generally curious. I'm Tim Newton.
I am Matt Parker.
This over here is
Jason Reed.
And today we are graced by the presence of Dr. Foad Dizadi-Bahmani.
Very good.
Oh, I got through it. Thank you very much.
And let's not forget our lovely camera operator tonight is Laurel.
Woo!
And we're graced by the
guest
presence.
dog.
Yeah, guest dog Sai. Some viewers might remember Sai from a year and a half ago. He did that Christmas. Sorry, folks.
That's okay. We'll be fine.
All right, we've got it all sorted out.
We've got it.
So,
on song.
Foad's an old friend of mine. He was actually one of my students in my second year at the LSE, and now he is teaching philosophy at California State University of Los Angeles, Cal State LA.
Mm-hmm. Shout out Cal State LA.
And of course, Laurel, Margaret Laurel, also actually graduated from Cal State LA, did her undergrad there. Represent. And Foad's a philosopher of physics.
Nice.
So what kind of crap do philosophers of physics do?
Foundational ideas about physics. I don't know, what do? We sort of worry about the things that even the physicists don't worry about. I think it's the best way to put it.
Really? And when you, so how many of you are there sat there worrying at Cal State?
At Cal State, there's just yours truly.
Oh, really?
You're
You're doing the worrying for the team.
Yes. But worldwide, there are probably maybe 7. I know, but it's a very small community. I think probably fewer than 200.
Great.
Mm-hmm.
And do you circulate your idea? Are you going, oh, I'm worried about this today, or anybody else worried about this? Is there like a Facebook for physics philosophers?
If it is, I haven't been invited.
Oh.
There is an old Phil Fizz email.
Wait a minute,
list.
Phil Fizz.
Yeah.
Oh, we like this.
That's what the email list is called. Right?
It's called Phil
And
Fizz.
it's still alive, surprisingly, even to this day. Anyway, so you've come here to talk to us about this idea that's very popular in fiction, right?
True, yes. Parallel worlds.
Oh, my favourite.
Is it?
Oh, well, I love it. I do like the parallel worlds. But
Yeah, so it's done the rounds in science fiction for a very long time. This idea that there are worlds that are more or less similar to ours. They can get very fanciful on the one end and sort of very nearby on the other. But what's interesting, I think, and maybe this is what we're going to be talking about today, is that there are several not entirely batshit crazy ideas for why you might take this seriously. So it might be, as it were, better than science fiction.
So there's more than one theory about why there are parallel worlds. Is that what you mean?
That's correct, yeah. So I think there are at least 3, although we were talking before the show that there's actually maybe 4.
Possibly 5.
Possibly an infinite number if...
Yeah. And then there's another possible world.
Yeah.
Probably 7.
Yeah.
But in this world, there's only
5.
Well, because...
We're getting ahead of ourselves. I mean, I don't even know, but the only one I'm aware of is your classic quantum theory, multiple worlds. As quantum leap, for example. I mean, that was doing it 30 years ago, wasn't it? Jumping around between parallel worlds. And it's a very popular theory, one that's gained, because I think as I said to you earlier, I heard that you opened a lecture once talking about an episode, one of my favourite episodes of Family Guy, which was basically a Family Guy episode where they were jumping through alternative.
So someone has a remote control.
Yeah, Celia had something, and they were hopping about, and they were trying to get home. They were doing their own kind of quantum leap, basically, because
Mommy.
Mom. Yeah, and there was that one where they were entirely drawn by Disney, I remember, which was really hilarious.
Oh, that was one of the possible worlds.
That's one of the possible worlds where they're drawn by Disney. One where they had one had 2 heads, one that was happy and one that was sad all the time. One where the dogs and the humans were reversed, so dogs ruled the world and humans. But exactly. So I mean, that's how popular that idea is. And people love it. I mean, because it's very appealing.
It's very suggestive, right? And I think it's even more suggestive when you start to take it seriously. Like, you do get these sort of very... Occasionally when I let myself take it seriously, I'm like, gosh, if that's right, it really is the case that there is someone who's awfully like me, who really is out there, and is even sort of having similar, somewhat skeptical thoughts about that being the case also.
But yet making better choices.
Yes, being with you.
Yeah. There's a nearby possible world where this show is already funny.
Yeah, and incredibly popular. No, but that is the case, isn't it? Because immediately, because it is very romantic. I'm having a bad day, and there's one of me, where I'm king of the world, or.
So you take a certain level of comfort from the thought.
I find it's got that sort of like it's got that same sort of level of comfort that people get from heaven and hell and that kind of heaven, not hell.
I've long been reserving this idea for a power pop song where the beginning is, in a nearby possible world, we're still in love with me.
Yeah.
And that's all I've got.
Yeah. No, but it's a good opener.
It's a good start.
But people would get it because it's sort of filtering into popular consciousness that. But the reasons why are really hard to fathom. You kind of go, it's something to do with the fact that things split off. That's parallels. That slit experiment where they shot little.
The 2-slit experiment?
Yeah, the 2-slit experiment where they shoot a little photon goes through there, but it goes both. So suddenly, that idea of branching out into worlds is, gaining traction in terms of like just popular understanding, I imagine.
So that's we're sort of touching on one of the ways in which you get possible worlds. So via this particular interpretation of quantum mechanics, it's sometimes called the many worlds interpretation of quantum mechanics. If you're more in the technical literature, it's called the Everettian interpretation of quantum mechanics, named after a fellow called Hugh Everett.
From the Eels, right?
Father of the singer of the Eels. Yeah.
Sorry, not the Eels. But yeah, okay. So, so how does that go? Like, how do we get parallel worlds out of quantum mechanics?
So the experiment to which Tim was just alluding is a nice sort of example of that. There's this. Quantum mechanics is already pretty complicated, and I've been told not to delve into the technicalities
Go a
there.
bit. You can dip your feet.
So imagine you have an infinite dimensional Hilbert space in which vectors are... I'm joking. So just in a very sort of rough and ready sense, one way to interpret what's going on in quantum mechanics is that whenever the standard version of quantum mechanics that you're taught, it says that whenever you perform a measurement, before the measurement there are a series of different possible outcomes, for each of which there's an associated probability, and then upon measurement you get one of those particular possible outcomes, and it's a matter of chance. So that's the standard sort of version of quantum mechanics that you would be taught as an undergraduate taking a physics course at a university. It turns out that that version is not tenable. I won't go into why.
Right.
It's just not going to work out for you guys if you're of that view. And then there are various alternative ways to solve what's called the measurement problem. And one of those ways is to take seriously the idea that rather than upon measurement it being the case that only one of those possible worlds is selected for, in fact, all of them are instantiated in parallel worlds. So that, indeed, sorry, all of them are instantiated as a technical nonsense term from philosophy. Thank you, Matt. All of them, in fact, happen. So the idea is that before measurement, there is a series of possible outcomes. Then what measurement really is the branching of the world into all these parallel worlds, each one associated with each of the ways that we used to think of being one of the possible outcomes. Right. So just to make it simple in terms of the experiment that you were talking about earlier, if it's possible that it went through the left slit or it's possible that it went through the right, and we don't know which, we say like, hey, it's got a 50-50 chance of going through both. In this interpretation of quantum mechanics, what you say is that, in fact, the world branched, and in one world, the electron went through one of the slits, and in the other world, the electron went through the other slit. And the other one that often people sort of know about, the Schrödinger's cat example, so it's often stated, oh, we have this cat, it's sort of according to quantum mechanics, it's in what's called a superposition of states, it's in superposition of either being alive or dead. On the Everett interpretation of quantum mechanics, this many worlds interpretation, what you end up saying is that, in fact, what happens when you open the box with the cat inside, the world branches into two. There's one world in which there's a live cat, and there's one world in which there's a dead cat.
Okay, I want to be a little bit picky there. So sort of on the modern...
You're going to be picky about that? That was pretty good.
Just a little bit. That's quite good. But on sort of the modern decoherence version of the Everett interpretation, actually, the cat doesn't branch when you open the box. The cat already branches when the particle strikes the poison vial or whatever it is, right?
Right. So you have an infinite dimensional Hilbert space on which, you can go.
Yes. Yeah. So
it's
the cat is both alive and dead.
No.
Neither alive and dead.
No.
Until you open the box.
That's the classical way of putting it. That's a
right.
poor choice of words. Well, that's the
Right.
standard way of thinking about it.
Right.
But on this new way of thinking about it, what you should say is that, Matt's right, it doesn't happen when you open the box, but at a certain sort of fuzzy, it's hard to pin down exactly when it happens, but at a certain point...
Once a bunch of particles interact,
they become what's called entangled.
Right.
And you get this thing called decoherence.
Yeah.
And in virtue of decoherence, the world ends up branching into almost classical worlds.
So how much of this is actually being observed in laboratory conditions, and how much of it is theorized, is theoretical?
That's a good question. Here's the most charitable answer I would give. I think there's very good empirical evidence for taking seriously the formalism of quantum mechanics.
Right.
So physics is in the business of giving us mathematized models of the world,
Right.
and then we test that against experience.
Right.
It's undoubtable that quantum mechanics is extremely well confirmed as a theory, and I think that's a sense in which we should take the formalism of that theory seriously.
Right.
And then it follows from some very technical and interesting work that there is this process that Matt was talking about. It's called decoherence, and it's a sensible interpretation of that formalism to see it as branching worlds.
Right.
So the theory is very well confirmed, but the interpretation that what's happening is branching worlds rather than wave collapse is very theoretical. It's very theoretical.
Right, but the danger is that so I'm sort of stuck between a rock and a hard place, because on the one hand I don't want to poo-poo this idea. I want to take it seriously. I'm also not an advocate of this view for reasons that we probably won't actually get into today. But what I would impress upon everyone listening is the following. It's like we would be doing ourselves a disservice by saying, hey, what direct evidence is there for parallel worlds? There isn't any, ergo we shouldn't believe in it. That's not how physics works in general, never mind about parallel worlds. I think the right thing to say is, hey, physics is a formalized model of the world. There's ways of testing that formal model. When you have good empirical evidence that supports that model, you should take that model seriously. And then it's perfectly legitimate to imagine what the theoretical implications of that model are about what the world is.
Even if you don't have empirical tests of the implications, we have tested the theory. We take the theory seriously. We should believe the implications even if we can't test them directly.
And in fact, there's no such thing as direct testing anyway. That's also misleading, but that's for another.
That's a whole other topic.
That's a whole other. Okay, yeah. So basically, we're having to take your word for it.
No, that's unfair.
Well, I mean,
not my word personally. I didn't just come up with it.
That's right. But unless you want to, really sort of study up on quantum mechanics and the arguments for the different interpretations, then you have to take someone's word for it, or just shrug your shoulders.
Right. And I think, look, on the one hand, I think in general arguments, led by authorities and that we should be skeptical of. I would, from my own point of view, what was really interesting to me when I was thinking about all kinds of different parts of physics was that there's some very, it sounds outlandish, right? Oh, there are parallel worlds. This is sort of very fancy science fiction. But what's interesting is that there are some very rational, serious-minded folk, physicists and philosophers of physics who sincerely advocate this view. So it's not mere science fiction. I think it's an open question in the foundations of physics.
Some people have said now that the Everett interpretation is now the most popular among physicists.
There you go.
Amazing. I don't know if how true that is, but
that's an open sociological question.
Yeah.
That's the one that physics physicists, all philosophers are warming to. But there are other science guys. But there are other theories that are competing for that, or can they exist side by side? Because there are other ways of saying, oh yeah, parallel worlds are caused not by quantum, but by X, Y, and Z. Because there are a number of different theories.
Yeah,
do they coexist, or are they in competition with one another?
Yeah. So just to be clear, there are different interpretations of quantum mechanics. The only one that gives you many, like these parallel worlds, is the Everett interpretation. Right. Now, there are independent, nothing to do with quantum mechanics reasons for taking seriously the idea of parallel worlds in a different sense. And one comes from cosmology. Again, very roughly speaking, the idea is that in the early universe, as space-time is sort of expanding, it's theoretically possible that there are sort of distinct bubbles, and one of those bubbles is what we see as our universe. And there are these distinct bubbles that are formed where in some sense the underlying basic physics is the same, but maybe some of the constants or how that world works at a more macroscopic level might be different. So there might be parallel worlds in that sense. There might be other universes, in some sense similar to ours, but also different, out there.
Where gravity works in reverse, for example.
I don't know. Well, gravity might be stronger, for example. That's at least more plausible, I think.
Right. Okay.
Where it's not 1 over r squared, which is how the gravitational field drops off.
So this bubble theory is saying, there's there are other potential worlds, and I'm assuming potentially infinite number of worlds.
Sure. Yeah.
But all of those are kind of like ours when it comes to the physical laws that we worked out here.
Kind of like ours, but not very, right? So that they're like, you might still have gravitation, but it has a different strength, or it follows a different law or something. So and if one of those things is tweaked even a little bit, then the world,
the macroscopic world that you have is going to be radically different. Oh, that was insane.
See, we go way back.
So so these bubbles, they were formed. You say it was a cosmological argument. They were formed what? At the same time as our universe, or have they grown out of our universe like polyps, or what?
There's no sort of time relation, I think, between these things, because time is one of the things that emerges within an inflationary universe. If I got that right.
Oh, so they've all got their own time.
Yeah, they've all got their own time, their own sort of concept of time. There's no time relation between them.
No. So in general, and this holds for both the Everettian viewpoint and the cosmological one, and the last one that we will talk about, hopefully, which is the possible world one. One way of thinking about what a parallel world is to imagine it or to conceive of it as something that's concrete in the way that like our world is concrete, but
every bit as real as ours.
Every bit as real as ours, but to which we have no spatio-temporal relation. So what I mean by that sounds fancy, but all I mean is that you stand in some kind of spatio-temporal relation to the moon. It has a certain distance from you, like a physical distance. It's a long way away, and like Alpha Centauri could be even further away. But the point is that anything in our universe is something to which you stand in a spatio-temporal relation to. You don't stand in any spatio-temporal relation to these things of these other parallel worlds.
Right.
So
it
I
could
can't
be
say that
here as well. It could be within us, around us. It's not because when you talk bubbles, obviously immediately I think bubble, and then I think of other bubbles. I think, oh well, they're kind of stuck on there. Bubble. They're bubbles and they're taking up space in the way I have to imagine it. Yeah, what you're saying is actually no. All these bubbles could be in just one space like that.
I would say that there's no spatial relation between them whatsoever.
It just doesn't make sense to say they're in the same place or they're in different places or they're a million miles apart.
Oh. Ida?
Nicely, there's a possible world where this didn't happen.
This did not happen.
Yeah.
So that's
I'd
nice.
like to be in that possible
Yeah.
world.
I'm just wondering if I've got any.
Ida?
Ida?
Hey, Dave.
Oh, Edith.
All right, you guys prattle on. I'll clean up my mistake.
Well, that's fine. Bye now.
So there's no way. So talking in terms of space and time with these things is irrelevant. You're saying because it's not relevant. There is
Been
no
in a
connection.
different space and time.
They're at a different space and time.
Yeah.
So look, there's a sense in which you stand in a temporal relation to yesterday.
Yeah.
And you stand in a spatial relation to that house over there and the moon and Alpha Centauri and however else. So you stand in both spatial and temporal relation to everything in our universe. The point is these things are not in our universe. There are these separate universes. So it doesn't make sense to talk about whether or not we stand in... They're not... It's like, is that universe ahead of us or behind us? That doesn't make sense. Is that universe further or closer to us? That doesn't make sense. The universe itself defines everything that we have access to, everything that we are spatio-temporally related to. This stuff sits outside of that.
Yeah, and yet our universe is in infinite space.
Well, that's an open question. It's I think most people would say that it's probably not in infinite space, but it's pretty big. But in any case, even if we assume that it's infinite, the point is that everything in our universe is still spatio-temporally related to us.
Yes.
So it's infinitely far away, but it's still far away. It stands in some sort of temporal relation to us, some sort of spatial relation to us.
So funny you should bring that up because if in fact each of these...
Are you going to complicate matters?
Because if in fact one of these, even if in fact even one of these inflationary universes is infinite, spatially infinite, then that gives you another kind of multiverse. Because if it's infinite, then there's a lot of things that happen within that universe, right? And so somewhere very far away, outside of our light cones, further away than we can ever see, there are worlds that might be quite a lot like ours. There might be infinitely many worlds with people just like
the
us
argument
on it.
that if there's an infinite amount of, if your universe is infinite, then you can only go so far before you'll come across the same combination of atoms because there's only because there's only so many ways that atoms can combine. So eventually you'll come across a version of yourself because it's probable.
Right.
So that's
another version.
That's another kind of multiverse.
That's the fourth one that we were. Remember at the beginning when we were talking about four? I said three. I said four. The fourth one is the one you just.
So that is just letting infinity run its course.
Yeah,
really.
But if you think about it,
that's a nice turn of phrase, Tim.
It's bad.
No, it is.
Because eventually, blah 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 blah, you will bump into yourself. Like I said, but what's really interesting about this is there are lots of really there's an accumulation of arguments for parallel universes.
Yeah.
So maybe what I'm thinking is before we sort of start to think about what those implications are, we should talk about the third one. The third one, yeah.
So we've done one.
Missing link.
So just in case everyone's getting lost, we're bouncing around a bit. The first one was the kinds of parallel worlds that you get from quantum mechanics. The second one is the kind that you get from considerations of cosmology. The fourth one is the ones that you get when you start thinking about our universe itself just being infinite and letting, to borrow Tim's nice turn of phrase, infinity run its course. You might sort of get repetitions, you get worlds like very similar to ours. And the third one is a philosophy one, so it's not sort of rooted in fundamental physics, but I saw a skeptical gaze, audience.
No, I'm going. Oh, I'm not skeptical at all. No skepticism.
It's a theory called Modal Realism.
Right.
It's due to a philosopher called David Lewis, and Lewis thinks that there are an infinity of possible worlds. So, on Lewis's account, are there like suppose that Everettian quantum mechanics, the first one that I described, is true. So just if that one were true, there are just infinite number of worlds anyway.
Yeah.
But on Lewis's account, there is an infinite number of sort of an even more imaginably larger infinity of possible worlds. There's a possible world.
Even more unimaginable.
Unimaginable.
Okay.
Sorry. Yeah. There's a possible world for each way that our world could be. So there's a possible world, according to Lewis, where literally everything is the same except this is just like this.
Yeah.
And there's a possible world where everything is exactly how it is here, but this is just like this. Now you can see just with respect to these two objects alone, you're going to generate an infinite number of worlds just twiddling with these two things. Now imagine you can start twiddling with everything. And now imagine that you can give up on the laws of physics. So on Lewis's conception, there are possible worlds where the laws of physics are entirely different. So on the cosmological one that we were discussing earlier, the basic laws of physics still have to be the same.
Right.
And then things can go sort of like wrong, if you will, at the more macroscopic level. On Lewis's view, even fundamental physics could be totally and radically different. And in fact, there's a possible world associated with everything that you can imagine except for what's a logical contradiction. So there's no possible world at which 2 + 2 = 5. There's no possible world at which a circle is a square. But other than that,
how did he arrive at that then? How does he go? How does he go?
It's like Tim's done this before. It's asking the right questions.
Okay. So how did he arrive at that idea?
It's wild. This one's the really wild one.
Okay.
There's a possible world. Strap in, folks. Take your wine. The plonk is excellent, by the way.
It's not bad for £2.29. It's a winner. Yeah. So. Have I been talking a lot? Maybe I should
No,
go on. No. Yes, don't back off.
Let me say this.
Oh, but no.
No. But let me ask. I mean, so no. Just go on.
Oh, really?
Yeah, tell us how. Because then
why,
we've got all
why
four
does
in our
Lewis
heads.
think that these worlds really exist?
Lewis thinks that these worlds exist for the following reasons. So we have to take a step back. We have to think about what existence is in the first place, according to Lewis. Lewis advocates, roughly speaking, a meta-ontological position. That's a fancy way of saying how we decide what we should believe exists or not, which goes back to a philosopher called Quine. And Quine says we should be ontologically committed, i.e. we should believe the following things exist, which things, whatever is that we end up quantifying over in our best conceptual scheme. I know this is getting technical, I'll unpack all these notions. So Quine says some...
Can I just jump in there?
Yeah, go
so
ahead.
Like, if you have a theory that says that that there's a certain force that attracts bodies, then you're committed to the existence of that force. Or if you have a theory that says, for example, like for all rational numbers greater than 72, blah blah blah, then you believe in rational numbers.
Right. Yeah.
So anytime that you have a theory that plays an important role in science, that talks about these things in such a way that you want to talk about, there are some, all of them are like that, then you believe that these are things.
That's called quantification.
Yeah.
So I'm quantifying over electrons if I'm positing as true a theory that says there are electrons. I'm committing myself, according to Quine, to the existence of numbers if I end up putting forward and advocating a theory that ends up quantifying over numbers.
Okay.
So this is not a prescription about what exists. This is a prescription about how you should think about what exists. So Quine's not saying X, Y, and Z exist. He's not saying that electrons, numbers, and trees exist. He's not committing himself to a particular ontological view. Quine is giving a general sort of answer to the question, what should we believe exists? And his answer is, you should believe what exists, well, whatever you end up committing yourself to when you put forward your best theories about what the world is like.
Okay.
So, if you adopt Quine's meta-ontological position and you're like a sort of...
So having faith in these ideas.
Well, if you're not a naysayer about physics, you're going to believe in the existence of atoms. Because every theory of physics that we have going ends up quantifying over atoms. Let's say for the sake of argument. And now, if you come up with another theory that you think is somehow better in the sense that it's more empirically adequate or something like that, then that theory, let's say string theory, then on that view, you think that strings exist.
Okay.
So far, so good?
Yeah.
All right, so how does Lewis come into it? Lewis makes the following observation. However we end up doing our best physics about the world, it's going to be inevitable that we make what are called modal claims. Modal claims are claims that involve possibility and necessity. So Lewis's main idea is that it's going to be inevitable that we make not only prescriptions when we're doing our best science about how the actual world is, but we make prescriptions about how it could be. And that matters. Let me just give you a really sort of clear, concrete example of that. Suppose that you consider the sentence, nothing travels faster than the speed of light. There's a sense in which you could read that as, it's impossible for something to travel faster than the speed of light. And then that way of thinking about it is to say something modal. It's a possibility claim. It's not just like, oh, it's stronger than the mere claim that, everything just happens to be traveling slowly. Do you see what I mean? Like, nothing in this room is like, these two things might not be traveling faster than the speed of light. But that doesn't capture what's going on in relativity theory. Relativity is saying something stronger than that, saying it's not possible for something to travel faster than the speed of light. So Lewis's observation is that we end up using modal notions in the context of doing our best science. And because we end up using modal notions, we should be ontologically committed to those things that we end up quantifying over in doing our best science. And those things are what are called possible worlds. So
therefore he believes that these other parallel possible worlds exist.
And this is, I always find this interesting because people are just like, what? Why? I don't understand why you think this.
But that is because he's committing to the idea that they exist because he has a theory that they exist.
Let me put it slightly more crudely, but more intuitively. For Lewis, committing to possible worlds existing is no more bizarre than committing to electrons existing. If we end up quantifying over them, we should. That's what it is.
That's an incredibly open mind he has there, though, isn't it? Because he's going, anything's possible.
No, it's not just anything's possible. There are no round squares.
Right. Oh, right. Anything's possible.
Anything that's logically consistent is possible.
Anything that's logically consistent.
Anything that's logically consistent actually happens.
So anything that can happen will happen somewhere.
Yeah.
That's true.
Though, except for the where, because these
it's
worlds
not technically
are spatially...
And that's actually why I wore this T-shirt. Because this is a nice representation of all these different possible worlds.
Yeah.
In Lewis's sense, like these like little nearby possible worlds and faraway possible worlds.
Yeah.
So in this one...
That's the actual world, let's say.
Yeah.
Right.
This is the world where we're all like hanging out here. And here's a nearby possible world where everything's the same except the Planck is actually Baron de Tour's 2011 from Waitrose 897.
Is there so within these worlds of Lewis? Is there anything really significantly different?
Yes. Lewis's view is the most radical view. So in Lewis's view, you name it and it's there, except for the logically inconsistent.
You see, that's the thing.
So there's a possible world in which you're a fish.
So there'd be a world in which the meteorite didn't hit the Earth, and we're sat here as a bunch of highly evolved dinosaurs doing a podcast.
Yes.
Because it could happen.
That's logically consistent.
Yeah.
Within the bounds of... Oh, but logic, not physics.
Right. So it's far... Exactly. This is the sense in which it's far more permissible.
Yeah.
When we go back to the Everettian, the quantum mechanics view, it's very restrictive. What's possible is only what's possible with respect to.
But
quantum
can't there be a
mechanics.
word? Can't there be a world then where the word for square is circle and the word for circle is square?
That's
and
just
and
language.
Circle
That's
is
just
square.
language. Jason's got the idea.
Yeah. So, but,
Sure, definitely there are worlds like that, right?
Yeah.
I mean,
That's an easy one.
That's, you could go across the
Yeah.
channel.
with
speak
any
funny.
of these theories,
Funny language there.
yeah.
it's
Immigrants.
kind of different words.
All
Yeah,
kinds of crazy words.
So, but yeah, the thing I think, I suppose the thing I'm struggling with though
This
is
is a
who's
process.
defining the logic? Who's defining that logic? Who's saying
That's an
that
excellent
logic is
question.
true? Because he says it's true. So what? In my world, it's logical to me that eyeballs, are rubber and can bounce to the moon.
Do you think logic is
But
purely
why can't
subjective?
someone think that though?
For sure they can think that. The question is whether their thoughts are tracking reality in any sort of sense.
No,
So
but
who's
is it
deciding
true
that his
that
thoughts
there
are
are different logical truths in different worlds, right? So I think a mainstream way of thinking about logic is that it sort of captures, that it derives from sort of the meanings of what we say, and the things that are illogical are just the things that really don't make any sense. Like to say that I'm a potato and I'm not a potato, that's logically impossible just because it doesn't make any sense to both be a potato and not be a potato.
So who's defining what makes sense though?
That's a fair question. I mean,
He is.
not Lewis. Lewis is taking on board.
So he's absorbing what he
classical
likes.
logic.
Right. Okay.
I
see. So he's going. Yeah, classical logic works for me, and so I can imagine everything, but it has to be rooted in classical logic.
Well, it has to be at least consistent with classical logic. So, I think Lewis might say that you can't really imagine, a contradiction. You can't really imagine a potato that's not a potato.
Give the stronger example. I mean, can you literally imagine a circle which is a square? And look, it's sort of more than that. It's not just like to do with like our abilities to imagine. I sort of don't want to tie it to literal imagination.
Yeah, it's not a psychological thing.
It's not a psychological
that's it, because
thing.
that's
It's
what I'm
stronger
finding.
than that.
Because for me, it's the idea of imagining all the possible worlds, except for things that stick to logic, isn't that far from just going, well, anything. Do you know what I mean?
But what is it for something to be a circle? And think about what it is for something to be a circle. Now think about what it is for something to be a square.
Yeah.
A little bit of thought, someone like Lewis would say, was convince you of it's not possible for something to satisfy both of those properties at the same time.
Right, okay.
It's not possible for something to literally be both circular and a square at the same time.
So, but is there another theory of parallel worlds where it could be? It's just that it's beyond our realm of imagination.
No, but Lewis has a nice term for that, and he makes a distinction between what's possible and what's conceivable. So right now we're conceiving of a round square. I mean, we're talking about something.
Yeah.
So we can conceive of a round square.
Yeah.
But that doesn't make it possible. So like being able to conceive of something is even weaker notion, logically speaking.
Right. Okay.
So we're sort of entertaining what it would take for something to be both square and round at the same time.
Yeah.
So we're conceiving of that.
Yeah.
But then we're convincing ourselves that in fact no some such object could exist.
And is this the case for every possible parallel world, wherever the theory originates, whether it comes from a quantum source, a cosmological source, a philosophical source? Are we saying that there are certain things that will be in every world?
I'm not sure I understand the question. So
no, I'm just you're saying. So Lewis's idea is that you just because you can conceive of it, it's not possible. Okay.
Yeah,
right,
so conceiving of something is not enough.
So yeah, so that's what Lewis.
So you're saying there's another parallel world.
Is there a parallel world?
Lewis's ideas are completely refuted.
Potentially, but no. What I'm saying
because
is that we're talking about where all these different these different theories of parallel worlds originate. Can it be that that particular lock that Lewis has put on the possibility, right, is off?
Yeah, so all
cosmologically,
all the
quantum speaking, are we talking the same? Every possible world that could ever possibly be can't have a square circle in it.
Yes.
Are we really?
There are no square circles anywhere.
anywhere in any world.
I'm going to commit myself.
Are you going to
to
stick your neck out and say no?
What would a square circle be?
Yeah, what is it?
What would a square circle be? It just doesn't.
See, like,
Well,
just,
no, it's not
it's
just
just-
this. We can't think of it. Is there not?
no, it's more than that.
Well,
We
if
have
we
good
can't-
definitions of both of those things, and we can prove that.
We do.
Yeah.
What is it?
Yeah.
Is it like a round thing with a box inside?
Well, I don't ask me. I'm not saying I know. All I'm saying is, why are we locked to that idea?
Let me give you a slightly different
Because of
example.
our consciousness.
I think there's a sense in which when we're imagining objects, it's sort of more suggestive. Let me give you a slightly different example.
Yeah. Okay.
Is there a possible world in which you think 2 + 2 = 5?
Why not?
Well, because here's what I would say to that. I would say, if I know what 2 is, and I know what addition is, and I know what equals is, and I know what 5 is, I can just prove via a deductive argument that that's not possible. It leads to, it's called a reductio, it leads to a contradiction.
In any world, then.
Well,
all these
in all
infinite
the-
As
worlds.
long as 2 and
Means what
plus
we
and
mean by
equals
2.
and 5 mean
Yeah,
the
what
same
we mean
thing.
by 2. Yeah.
Sure, but then you're going back to the language, right? The language could differ from.
Well,
could
I'm
vary
not,
from
I'm
one to
not
one.
saying that necessarily language. I'm saying there is things that we can't. More in heaven and earth a ratio than is dreamt of in your thought. You know, is something that we. It's only stuff that we can think about.
You're not
yeah.
giving yourself enough credit.
But-
There's a sense in which you're sort of trying to be very sort of intellectually humble, and you're like, look, sure, maybe we can't think of it, but why would we then like want to rule this out for everybody?
But you're imagining a world in which every time you've got 2 glasses of wine, you've in fact got 3,
Yeah,
which is quite a good place.
yeah. I've experienced that in this planet, on this world.
Yeah, that's more to do with the wine
Late
than
at
the
night. Yeah,
physics.
exactly. But what I'm saying is this is interesting because what it means is there is a certain because the exciting thing about parallel worlds is anything's possible
Well,
except
I
for
wasn't-
these
What's
things.
impossible?
I was not going to say this because I sort of don't want to give philosophy a bad reputation, and I don't. But I will just throw this out there because it's touching on what you are talking about. There is at least one philosopher who I know of who advocates not just the existence of possible worlds, but also impossible worlds. So according to her, there are possible worlds where there are indeed, well, there are impossible worlds in which there are square circles.
But concrete worlds as real as ours where square circles exist. Who is this?
Nora Bernstein,
Okay.
I think. Oh gosh, I've said this on live.
I was
Oh, Nora.
I was
If
going
you're
to.
listening, Nora, write in now with your counterpoint to this.
No,
Yeah,
I'm
yeah.
pretty sure she gave a talk that I heard in which she was advocating for impossible worlds. Now, you could advocate for impossible worlds in the technical sense that philosophers talk about it without the extra Lewisian ontological commitment. So she might, this is what Matt was asking about, I can pass his technical question because I'm familiar with what he's asking.
Yeah.
So I'm not sure whether she would commit herself to the actual, to the concrete existence of these impossible worlds. But it's definitely true that she advocates for, at the technical end talking about impossible worlds, and that's kind of interesting.
Yeah, and there was Meinong as well, who
Oh man,
didn't,
now you're really
didn't talk
philosophy a
about
bad
parallel
reputation.
worlds, but who spoke of anything that we pose in our language, right? When we talk, if the very fact that I can say there are no such things as square circles,
Yeah.
implies that I'm making a statement about square circles, which implies that in some sense square circles exist, and I'm saying something about them.
So one way of connecting our two discussions on this point is to say something like this. Meinong took more seriously the idea that Lewis called just mere conceivability.
Right.
So for Meinong, if you can conceive of anything at all, then that object has a certain quality which he called subsistence. And now this stuff in the actual world has the extra further property of existing.
Yeah.
But all this other stuff, square circles included, subsists for Meinong.
Right. Okay.
It's a different kind of existence.
Yeah,
Yeah,
sort of
mm,
existence light.
Yeah.
Yeah.
But as far as
like
Lewis is
Gaia.
concerned, coming back to that,
Mhm.
that's not the case.
Yeah.
No.
That's insensitive.
So those things, for Lewis, everything that's logically consistent exists. If something is logically inconsistent, it doesn't exist. There's not this sort of second order, or sort of second type or existence light for Lewis. It's just you either exist or you don't. And Lewis was very clear about that.
No, I think because what that does actually fascinate me is the set of rules that there are, that have been laid down and are taken as being absolute. And like nothing can travel faster than light, that is taken as an absolute. So nowhere in any of these worlds would anything travel faster than light.
No. You see,
So where's the difference there then?
well, that's a mere, from Lewis's point of view, that's a mere physical law. So logical possibility is far broader than physical possibility.
Right, okay.
So from Lewis's point of view, there's a subset of all the possible worlds in which the laws of relativity are the same. Now, in all those worlds, nothing can travel faster than the speed of light. So that could be like these worlds are the worlds where there's relativity theory is true.
Yeah.
Within these worlds, nothing can travel faster than the speed of light. Outside of that, that's perfectly fine. But all of Lewis's possible worlds, let's imagine, are on this little T-shirt.
Yeah.
There's nothing beyond that, says Lewis, and this exhausts everything that's logically possible.
Right. So it's logically possible that something could travel faster than light. It's just physically impossible, given the laws of our world.
Mm-hmm.
Okay. Right.
So
there must be. We're not talking about a huge number of things then that are going to be absolutely, set in stone.
Within Lewis's scheme?
Yeah.
Yeah, no, not really. I mean, I don't know how you would count them, but the only things that are impossible in Lewis's schemes are things that just don't make sense at all. Like
They're just contradictory.
Yeah, they're just contradictions.
Straight up.
But this is very much, of all the thought experiments, that seems to me the most extreme of the thought
It's extreme and it's radical.
Because
I mean, let me ask you this. So we were talking about the parallel world from Family Guy where they're all drawn like Disney characters.
Yeah.
Is there a Lewisian possible world where there are Disney drawing versions of us sitting around talking?
Are you asking me whether I actually believe that?
Yeah.
Yeah, I do.
Yeah. Okay.
Yeah, straight up.
No, I don't mean whether you really believe they exist.
Do you think he would think that was logical?
Do those count as logically possible?
So Lewis would say yes.
Yeah.
He would say yes.
Oh yeah.
Even though we were drawings.
Yes.
Well, yeah.
Because
Sure.
Depends what you mean by we. But
Right.
there's a
That's a good
possible
point.
world. There's a possible world where there are things that look like us, that are drawings, that are having interactions, because I can't immediately see that there's a logical contradiction that follows.
Yeah, and
That's like outlandish to be sure.
Yeah.
And that's so far removed from what we think of as being physically plausible or sensible.
Yeah.
But it doesn't. If it doesn't lead to a straight up logical contradiction, then Lewis says that's perfectly fine.
Right.
So there's a sense in which we might think it's not now in terms of like spatial distance in the sense that like the moon's far away from us, but some more esoteric notion of distance. That possible world in which we're Disney drawings is pretty far away.
Yeah.
But because there's no logical contradiction to it, Lewis would say it exists. It's out there somewhere.
I think you'd make a good Disney drawing.
Yeah.
I think you would.
I think I was.
I could see us all
Was
now
I
as
in
Disney
Aladdin?
drawings.
I think I was.
You were in Aladdin.
Yeah.
I think one thing you can say is for Lewis, everything that happened in everything you've seen in The Simpsons and everything you've seen on Bugs Bunny actually happened somewhere.
Mm-hmm.
But the things that happen in Escher drawings don't.
Ah, that's a very nice way of putting it.
The things that happen in Escher drawings, it couldn't happen.
No, because
Because
it
it's not
doesn't make
drawing.
sense to have a stairway that goes up forever
It did
and
elaborate.
yet circles back.
You mean that wasn't real?
Yeah.
That was a bad dream.
Yeah.
Uh,
I see. Okay. So have we? So where else? What? So listen. So we've got quantum.
I am listening.
We've got quantum stuff,
Mhm.
right? That produces parallel worlds. We've got cosmological stuff.
Yes.
We've got logical stuff,
Yes.
and we've got just let infinity run its course.
Yeah.
Well, in
Where-
fact, we should reverse the order here because the one that Matt was talking about, this infinity, is like
Most basic.
it's the most basic kind of power.
Actually, can I put another structure on this, right?
Sure,
Because
yeah.
Max Tegmark, the cosmologist, and now quite popular writer, writes about this stuff. And so for him, the mere infinity of the actual world, of our world, that's called the level 1 multiverse, right?
Mhm.
Then the existence of all these other infinite worlds in inflationary cosmology, that's the level 2 multiverse. Then you have the branching worlds of quantum mechanics, that's the level 3 multiverse.
Okay.
And Tegmark has this idea, which is similar to Lewis's, which he calls the mathematical universe hypothesis.
Yes.
And which he thinks implies that the world is just a mathematical structure, and all mathematical structures exist.
Mm-hmm.
So that's the level 4 multiverse, which he thinks is slightly narrower than Lewis's multiverse, because he thinks that Lewis's multiverse is one where everything imaginable exists. And I think he's slipping a bit there, because Lewis doesn't believe in everything imaginable, but he believes in everything that's logically possible.
Right. Okay,
Right.
Which is different. This is
So
I don't
there's a
know
subtle
whether it's
difference.
I don't know if there's a real difference between what's logically possible and a mathematical structure.
oh, but imagine
Tegmark
what's
thinks that.
logical, possible, and imaginable is different. Yeah.
Yeah, that's right.
But
I have the intuition that like logical possibilities, there are things that are not mathematically possible, but nonetheless logically possible. But that's we
Yeah,
have to go
that's
there.
a
oh
whole
wow,
other
yeah,
philosophy of
that would be
mechanics today.
interesting. Or maybe it's too difficult to understand.
You're doing great, Tim.
Yeah. So, would there be any way to prove the existence of a parallel world?
Yeah.
What is proof, Jason?
Well, there you go. But
Proof is deduction from axioms. So proof is not what you're interested
would
in.
there be a way to find one, to visit one?
You see, what you're interested in is empirical evidence, not proof.
Can I just throw
Sorry.
something in there in terms of empirical evidence? So, from the point of view of inflationary cosmology, the idea that there are all these infinitely many worlds that sort of like inflate out of this growing stuff, right? The cosmological one, the level 2 multiverse.
Okay.
One thing that cosmologists have tried to do is figure out that if this theory is right, what is a typical universe going to look like?
Mm-hmm.
And if ours looks like the predicted typical universe, then that's some evidence that the theory is right.
Oh, if ours looks like what we're imagining it might look like.
If ours looks like what the theory says it probably ought to look like, then that's some confirmation.
Oh, okay. So how do you work backwards from this then?
Really hard, because it turns out that according to the theory, there's an infinity of these worlds, and it's a lot like trying to figure out what are the probabilities in an infinite lottery, right? So if you have infinitely many tickets in a jar, what's the chance that you're going to pull out 2017? What's the chance that you're going to pull out a number bigger than 99 billion?
If you've got an infinite number.
So here's the problem. Just with respect to the problem that Matt set up, it's like, on the one hand, you don't want to say that the chance is 0. It's like clearly there is a chance that you could get the number, which is 2025.
Yeah.
But the way that standard mathematical practice tells you should answer that question is it's 0. Because each particular one is of measure 0 in the overall set of infinite numbers. So then there's a sort of funny thing where it's like any finite number of tickets is going to have a 0 chance of being pulled. But that seems unintuitive, because like surely there's got to be a chance. I could just reach into the thing and pull out 2025.
So because I think that this is all this is the exciting stuff, because really I think all the jollies in fiction come from the idea that there's interference between these parallel worlds. If these parallel worlds, just go on and on, fine, whatever. When there's no, it's about the interference of the parallel worlds and being able to cross the parallel, or have these parallel worlds.
Yeah, that's a very good thing. So I would say it's not clear to me exactly what the level 3, the Everettian, the quantum mechanics one. Whether there is in principle empirical evidence that we can find. But so if I'm being very sort of precise in what I'm saying, I would say something like this. It's an open question as to whether or not Jason is going to be happy. So it's not clear to me that the answer is no to his question, but it's also not clear to me that the answer is yes.
Yeah.
That's the best I can give you right now. I'm sorry to say.
But
it's better than a firm no.
Yeah. I don't think that's our ending.
Were you hoping that we just go outside and be like, oh yeah, here's a parallel world, have a look. Have a gander.
No. Well, I think what's interesting is with all these theories, obviously, that it is impossible to prove.
I'm going to be a stickler about this. I'm going to say proof is the wrong concept here. Proof is not what we're interested in.
Okay.
Proof is just boring. Proof is deduction from axioms.
Yeah. So what's
We're
the
looking
word
for
I'm
evidence,
looking for?
empirical evidence.
So where's the evidence?
The evidence is indirect. So at least going back to this is where I started the hour by trying to sort of convey. It's like when we go back to at least the quantum mechanics version. Again, the point is that the theory has empirical confirmation. There are good empirical reasons for taking quantum mechanics seriously. Now, taking seriously is a vague and actually deliberately vague phrase here.
Yeah.
But I think you have an intuitive grasp of what I mean. This is not just made up science fiction quantum mechanics. There are good reasons for thinking that this theory is in some sense latching onto what the world is like.
Yeah.
But what the theory tells us about what the world is actually like is not clear. A turn of phrase that philosophers often like is, a theory doesn't wear its ontology on its sleeve. You can't just look at a theory and immediately go like, oh, this is the picture of the world that it's giving us. There's what's called interpretation. You have to figure out, hey, this is the mathematical formalism of the theory. Which bits of this formalism correspond to things in reality? Which bits are just sort of artifacts of the formalism itself? And how should we make sense of these things? And now, once you have that observation, you make the observation that there are different interpretations of quantum mechanics. And under one of those interpretations, we believe in parallel worlds. So then if you ask me what's the empirical evidence, I'm like, it's sort of indirect. You first have to sort of take quantum mechanics seriously. That's the part for which you have direct evidence.
Yeah.
And then there's the further, not just purely empirical question of how to interpret the physical theory. And that's up for debate, and that's a live debate right now. So there are people who are presenting arguments in favor of it. There are people like myself who are presenting arguments against that interpretation, and it's just an open question. It's different from looking through a telescope and just confirming that there is a particular planet out there. It's not, you're never going to have evidence in that kind of way for it. You're always going to have this sort of indirect, mediated by theoretical reasoning.
That I guess is the point. Is it, given all that we know, logically, physically, cosmologically, given all that we know, are we saying that we won't be able to do that ever?
To think that once you sort of once you get into this stuff, you realize that kind of thing is a bad way. It's a sort of unrealistic expectation. So it's not a shortcoming of physics that it's not going to give you a direct empirical confirmation. I mean, we said this earlier, and we sort of didn't want to dwell on it because it sounds like you're being a naysayer about physics, and we're definitely not being naysayers about physics. But the point is that physics is a package deal. It's not just purely empirical. It's empirical plus interpretation of mathematical formalism, all of physics, not just quantum mechanics. There are live and interesting debates about how we should understand relativity theory. What exactly is relativity theory telling us, if true, about what the world is like? So there's a sort of a misconception that, oh, science is just, you either confirm it or you disconfirm it. It's more nuanced than that. And that's not to be a naysayer about the practice of science.
No, that absolutely.
Is that fair, Matt?
Yeah.
I just think I'm just wondering that, you know, it's a little bit like, I don't know, it's having faith in those ideas, really, I suppose, because you know, you go, great, this is really exciting, it's wonderful stuff to imagine, and that's really interesting. I'm just wondering, I mean, it's like whatever, you know, the improbability drive in Hitchhiker's Guide or something like that. You know what I mean? It's a great thing to imagine, but it's not something that's actually something that we can experience outside of our heads. You know, we can't go into some great chamber where you go, every 5 seconds you'll see a flicker or something, and it's, you know, a portal to another world.
But do you think electrons exist in?
Yeah.
Why?
Yeah, because electricity. Because of electricity.
Yeah.
Yeah.
They make the
electric shocks.
They make the microphones.
Because of the electric shocks. I'll put that down. I take that to electric.
Do you think like distant stars exist?
Yes.
Why?
Because of what science has shown us with Hubble telescope and stuff like that.
Yeah, but those telescopes themselves are sort of.
Yeah.
I mean, they're themselves both mediated by, to use the technical term, they're theory-laden.
But they provide me with visual information, which I choose.
Not really. I mean, an electron microscope is giving you a picture, but it's not giving you. You're seeing a picture of something else. and whether that picture has veracity is itself, you have to assume certain things about how theories work.
Is it in a sort of way that it's not that we'll actually we'll see another world, but we'll find proof for another world, or that kind of thing, but they'll come to a stage where our own world can only make sense by what we understand of it if you accept that other worlds exist. So your theories, your conclusions, your understanding of quantum mechanics lead you to a point where even though you could not actually be able to sort of say there's the other parallel worlds, you could only say our world doesn't make sense unless you accept that there are parallel.
That's never going to happen, though.
So you guys had, if I may, guys had John Worrell here, I recall. And Worrell, I take it, was talking about Popper. And Popper's ideas...
Well, we were mostly talking about Lakatos, but we did touch on Popper a little bit.
Okay, so, I mean, there are interesting general considerations about the status of scientific claims and how we should conceive of scientific theories. There are different schools of thought about that. Let me just tell you Popper's, because I think it's persuasive in many ways. Popper is of the view that science, even at its best, in its most ideal form, is conjectural. So we'll never be able to, as it were, prove in your sense of the word prove, like that our theories are true. We're constantly testing our theories, and at best what we can achieve is the sense that we haven't managed to show our theories to be false. So there's a sense in which you can show a theory to be false. If it's not empirically adequate, if it doesn't account for the data that we have, then that's a reason for rejecting the theory. But you're never going to be, and this is just a logical point, you're never in a position to show that the theory is true in virtue of the empirical evidence for it. So that at best science is conjectural. Even if that's right, though, and this is the point, and this is the thing that I'm sort of nervous about when I'm talking about this stuff, because I'm worried that people listening will interpret this as me saying something like, oh, science is just a matter of belief, or science is like a matter of faith. And it's not that. The point is, that thing is even if it's conjectural, it's objective, and it has a certain value. It's objective, and it has a certain distinct qualities from things that are non-scientific or pseudo-scientific. So, and that's the important thing to realize. Maybe we're never going to be in a position to confirm as true our best theories. All we're ever going to do is have increasingly good evidence for not rejecting our theory as false. Those things sound very close together, but they're logically distinct. And for all that, that's more than just mere faith or belief or something like that.
So, okay.
Yeah?
Yeah, no, I'm thinking
it's not just, this is a cool idea, and it's not, we can look out the window and see it, it's in between. Right?
Yeah, which is sort of what a lot of philosophy is. In some respect.
And science.
And science, because you're kind of conjecturing on things. But, our subjective experience, this is the only experience that we can, with certainty, certainty say we'll experience. Is that right?
If we had a whole other hour, Tim,
I
would talk to you about...
and another bottle of wine.
And another bottle of plum. I would tell you all about counterfactuals and why you have intuitions about counterfactuals being true or false, and then convince you via that in fact that means that you're making sort of necessary recourse to possible worlds discourse, and that's a reason for taking possible worlds seriously. It's a whole hour to be told just about that. I think.
Well, maybe we should have you back.
Part two.
Part two. You can talk for that. Yeah, good. Okay. Well, that's good. I mean, what I'm sort of disappointed about, I think.
Don't say that.
Is we've got
we're out of time. We can't be disappointed with no minutes to go.
No. I'm sort of. I love the fact that there are lots of reasons for parallel universes, and we'll continue to be sort of excited by the notion of parallel universes because it's given rise to lots of interesting fiction and sort of exciting ideas. But yeah, I just find what I've been surprised by, I think, is the fact that there are more limitations than I thought. These logical limitations that I thought on parallel universes. Not that I can imagine a square circle necessarily, but the fact that the idea but my preconceived idea was that there is certainly would be a world where square circles were possible, and it seems that some people do say that, do think that still.
That's definitely the minority.
But that's the minority view. The majority view amongst philosophers is that certain laws are unbreakable. Really, the laws of logic.
The laws of logic, yeah,
are forever cast in stone at the moment. Yeah. No, it's all been very interesting. Well, we should.
Stop.
Yeah, we should.
We're out of wine.
We should. We're out of
definitely out of
wine.
wine. Yeah.
It's down to you to drink that last drop right here, right now, and for
Cheers,
us
gents.
to sign off and say, yeah, come back again and let's talk about that stuff you were just mentioning.
Sure, and Wittgenstein, maybe.
Yeah, and Wittgenstein.
And Wittgenstein.
Right.
All right, okay.
Not at the same time.
We can have let's keep them separate. But it's always good to have people like yourself on, giving us some fresh info for us to ponder over. Maybe out there, in some parallel Facebook universe. We've had some comments. Oh yeah, nice. So yeah, with that.
A 1, 2, a 1, 2, 3. I did that wrong. A 1, 2, 3. No, a 1, 2, a 1. Play!
Woo. Press the red button.
Press the red button.
Bye-bye.